To the Geometry Chapter 8 review. We'll be doing all kinds of fun problems and going through these answers. So the first one, number 1, consecutive angles in a parallelogram are always C, supplementary. They're certainly not vertical. They're not complementary. They do not add up to 90 degrees. And they're not congruent. If you picked congruent, you were thinking of opposite angles. In parallelograms, consecutive angles are supplementary. Number 2, choose the statement that is not always true. Well, for any parallelogram, the diagonals do always bisect each other. The opposite angles are always congruent. The opposite sides are always congruent. The diagonals are perpendicular. That is not always true of a parallelogram. That is true of a rhombus, but a rhombus is only one type of parallelogram. Number 3, if a quadrilateral is a parallelogram, its consecutive angles are complementary. That is false. The consecutive angles are supplementary. So number 3 is false. Number 4, if a quadrilateral is a parallelogram, then its opposite angles are complementary. That is also false. If a quadrilateral is a parallelogram, then its opposite angles are congruent. Do not confuse congruent and complementary. Hopefully I can speak. So use the diagram to find the given length. It's a little hard to read this, I think. I'm going to look. I think I have a paper with the problem on it, because this will work wrong if I can't read it. Oh, the paper is still bad. So we're trying to find AC, which is that part there. I'm going to make this a little bit larger because I really can't see that problem. Whoa, super big. So it looks like this is y minus 2 for A to this point, and this point to this point is, that's a 2, I think that's a 2. 2y minus 9. If this doesn't work, it's because I can't read the numbers. So the first part is going to be, we're going to subtract y from both sides. We get negative 2 equals 2y minus y is y minus 9. We're going to add 9 to both sides, and we're going to get y is equal to 7. But it doesn't ask us for the value of y, it asks us for AC. So 7 minus 2 is 5. And over here, 2 times 7 is 14 minus 9 is 5. And 5 plus 5 is 10. That is the answer on the answer sheet. So that's great. Not only did I do the problem correctly, I was able to read the letters. And for problem number 6, ABCD is a parallelogram. Find the value of x. So this angle here and this angle here are going to be congruent, because I have 2 parallel lines. There's one parallel line. This is the other parallel line. I'm just dashing them in so you can see them. Cut by a transversal, 51 plus x is going to be congruent to 132. 132 minus 51, x is 81, and that's what we wanted to find the value of, x. We have a proof here. I'm trying to get my scroll up here. Next page. We're given that VU is congruent to ST. So I'm going to start marking this up. VU is congruent to ST. And SV is congruent to TU. It might be easier than it So looking at this, we know that this must be a parallelogram. And we know that because just by looking at it, both pairs of opposite sides of a quadrilateral are congruent, and the quadrilateral is a parallelogram. So for number 2, our statement is VUTS is a parallelogram. So if this is a parallelogram, we know that Vx is going to be congruent because of xt, because if a quadrilateral is a parallelogram, then its diagonals bisect each other. And as you can see, this is a very simple proof. When we've had ones like this in class, we might end up adding in extra steps, talking about what the definition then of bisecting is. But on these proofs, this is more like what we would expect you would see on an EOC, and they just don't get that complicated when you're actually assessed on them. So that's what we'll do for that one. Not so bad, is it? Moving on. Number 8. Which statement is true? Well, all quadrilaterals are not squares. All squares are quadrilaterals, but that's not true. All rectangles are squares. No, it's the same way around. All squares are rectangles, but all rectangles are not squares. All parallelograms are quadrilaterals. This is true. If something is a parallelogram, it definitely only has 4 sides. It is a quadrilateral. Let's just look at the last choice. All quadrilaterals are parallelograms. No, there are all kinds of quadrilaterals that are not parallelograms, including kites and trapezoids. So 8 is C. I'm going to clear some of this writing here. Choose the statement that is not always true. For a rhombus, each diagonal bisects a pair of opposite angles. That's true. All 4 sides are congruent. That's true. The diagonals are congruent. That's false. Diagonals are congruent in a rectangle, which would mean if a rhombus is also a rectangle, meaning it's a square, then it's true. But we want the one that is not always true. Diagonals are perpendicular. That is true for a rhombus. So 9, the correct answer, the one that is not always true, is C. Which statement is not always true of a rhombus? This sounds like the question we just had. Let's go through it. The diagonals are perpendicular to each other. That's always true. The diagonals bisect each other. That's always true because it's a parallelogram. Rhombus is a type of parallelogram. Each diagonal is longer than at least one side. And the sum of the diagonals is less than the perimeter. I think this one actually might be a little bit more complicated than what we've learned in class. You have to actually apply some knowledge here. But let's say that's a rhombus. Okay? Okay, there's a diagonal. Well, just right away by looking at it, it looks like the sum of the diagonals is less than the perimeter. That's the one I don't know. And each diagonal is longer than at least one side. So let's look here. The diagonals are definitely going to be longer than the sides. The answer actually is number 10C. Don't think this one is actually on your test, but I wanted to include it in the review because I don't think the homework, at least that I've seen so far, and granted I'm making this video earlier in the review than we finished all the problems, really adequately discusses this problem. So for number 10, the answer is C. If the diagonals of a parallelogram are perpendicular, then the parallelogram is what type of figure? So perpendicular diagonals in a parallelogram make it a rhombus. Next one, that's a pretty easy one. A rectangle is a parallelogram. That's true. And this is the one that always makes people feel like so confused, but a square is always a rectangle. So that one's true, and that one's true. Opposite angles in a parallelogram are supplementary. That is false. Consecutive interior angles in a parallelogram are supplementary, but not opposite angles. Opposite angles are congruent. Number 15. If a figure is a rhombus, then it is a parallelogram. A square is a rhombus. Therefore, a square is a parallelogram. That is valid. And that is law of syllogism. I think on your test to take off testing whether it's a law of syllogism or a law of detachment, but I'm leaving it on the review because it's just a good review, but it's really not this chapter, it's really chapter 2, so won't put it on the test. If the statement, if a quadrilateral is a rectangle, then it is a parallelogram. That's true. Okay? The inverse of that, okay? If a quadrilateral is not a rectangle, then it is not a parallelogram. So if it's not a rectangle, then it's not a parallelogram. That's false, because a quadrilateral could be a parallelogram that's not a rectangle. Quadrilateral could be a rhombus and not a rectangle, but it is still a parallelogram. For problem 17, you have an isosceles trapezoid that has legs of J, K, and LM, and a base of KL. So they want you to find the value of x. Really, in this problem, they give you a little bit more information than you need, because all you really need is that since it's an isosceles trapezoid, leg JK, which is 8x minus 9, is going to be equal to LM, which is 10x plus 2. The pen is not writing well today. So I'm going to subtract 8x from both sides. I get negative 9 equals 2x plus 2. I subtract 2 from both sides. I get negative 11 is equal to 2x. So x is equal to negative 11 halves. For problem number 18, you're using the mid-segment theorem, the mid-segment formula for a trapezoid. So that's 1/2 of the base 1 plus the base 2 is going to be the mid-segment. So EF is 23. So the mid-segment is 23. We want to find AB. So that's one of our bases. And our other base, DC, is 26. So 26 plus x equals 23. So multiplying each side by 2, I get 26. That should be 26 plus x equals 23 times 2 is 46. 46, subtract 6 from both sides, and you get x equals 20. So AB is 20, EF, they told me, was 23, and DC, 26, which makes sense because 23 is the mean of the two bases. Next problem, I love this problem because it is a system of equations. So one side of a kite is 5 centimeters less than 2 times the length of the other. So whenever we want to write this, let's say one side, we're going to call that y, is going to be 5 centimeters less. So I always want to put my subtraction second. That way I make sure I do minus 5 and not 5 minus. And 2 times the other. Their perimeter is 8. So remember you have a kite here. So if this side is x and this side is y, this side is x and this side is y. So we have 2x plus 2y is going to equal 8. Those are my two equations. I'm going to substitute in this 2x minus 5 for the y value here. So 2x plus 2 times the quantity of 2x minus 5 equals 8. Which means 2x, 2 times 2 is 4x, 2 times negative 5 is negative 10, equals 8. 2x plus 2x is 6x. Add 10 to both sides, I get 18. X is equal to 3. So one side is 3, and then I can plug that in. 3 times 2 is 6, minus 5 is 1. So the other side is 1. I can make sure that works. 2 times 3 is 6, plus 2 times 1 is 2. 6 plus 2 is 8. So those are the two sides, and I did it with a system of linear equations, my favorite. For this problem, find the measure of angle T if R is 130. So that's 130. Measure of angle S is 60. I want you to find T. Well, I can see that this is a kite because it has 2 pairs of congruent non-opposite sides. So that means that these are the 2 angles that are going to be congruent. So 360 minus 130 is 230. 60 and 60 is 120. So 230 minus 120 is 110. So angle T, the measure of angle T is 110 degrees. For number 21, we're given that EFGH is a kite. That means those sides are going to be congruent and those sides are going to be congruent. Okay? So number 1 is given. They tell us that EF is congruent to EH and GF is congruent to GH. So your reason here is something like if a quadrilateral is a kite, it has 2 pairs of congruent sides that are not opposite. Okay, so you want to write something to that effect. That way you don't have to worry about if it's a theorem, if it's a definition, you have the words there. We're also told that EG, I'm going to put 3 lines there, is congruent to EG. That's the reflexive property of congruence. So now we should be able to get, oh, we have 2 triangles here that are congruent. Triangle EFG is congruent to EHG. There should be a little congruence symbol there. I know this is a little messy, you would write meter. And that is from side, side, side. So some of you are going to say, well, Mrs. Falk, how did you know that that's what they were looking for? Well, in number 5, they have corresponding parts of congruent triangles are congruent. Whenever we use that, I've said we use that right after we use a triangle congruence theorem. So what they wanted us to prove was that angle F is congruent to angle H, You can see that in the congruent statement there, and it is true because corresponding parts of congruent triangles are congruent. Okay, a lot of you are going to say for this next problem, oh, Mrs. Falk, do I need graph paper? I don't need graph paper. I'm just going to make a rough sketch here. So A is going to be at -1, -4. It's going to be some down there. B is at 1, -1. So that's going to be B. And that's 1, -1. And we said A was -1, -4. C is at 1, 2, 3, 4, 1. Okay, so that's C. That's 4, 1. And D is at 2, -2. So over 2, down 2. That's D. Okay. So when I draw that, I'm not even sure what that is. Maybe it's a kite. Maybe it's a trapezoid. The best thing to start to try and do is to fill in some dimensions. So I'm first going to look at lengths. So DC. I'm going to find the length of DC. So I'm going to do that over here and then fill it in over here. So I subtract my x values. 4 minus 2 is 2. I square that and I get 4. The other side here. The y's. 1 minus -2 is the same as 1 plus 2 is 3 squared is 9. So that is radical 13. Okay? So now I have to find the other lengths. I'm now going to do AB. I don't think AB is going to be radical 13, but I couldn't have drawn this bad, so let's see. -1 minus 1 is 2 squared is 4. And -4 minus -1, so -4 adding 1 is -3. 3 squared is 9. Now going back here, oh, I have 4 plus, it should be a 9. So, wow, that looks really bad. But that is a square root of 13. I want to double check my work here because I've made a mess. And if you're trying to watch this on your video at home, it's very confusing. So let me go through this again. A to B. -1 minus 1 is -2 squared is 4. -4 minus -1 or -4 plus 1 is 3. -3 squared is 9. 4 plus 9 is a square root of 13. Now I'm going to check CD. 4 minus 2 is 2. 2 squared is 4. And 1 minus -2, or 1 plus 2 is 3. So these are both square root of 13. So right now, I can rule out it can't be a kite. Okay? Now let's look at the other sides I have here. So now I'm going to look at D and A. To find the length of this side. So I'm going to look at A and D. Find the length. -1 minus 2. So -1 minus 2 is -3. And -3 squared is 9. And -4 minus -2. Wow, look at this. This does not look at all like what I drew. But -4 minus -2, so -4 plus 2 is -2 squared is 4. So that also is radical 13. And my last side is going to be CB. So 1 minus 4 is negative 3 squared is 9. Negative 1 minus 1 is 2 squared is 4. So all of these sides are actually the same length. So it's not a trapezoid. It's either a rhombus or a square. Now I'm going to figure out whether it's a rhombus or a square, determining whether these are 90-degree angles. So for this problem here, I was working on it, the computer crashed, I missed my horrible drawing, but we said that each side had a length of radical 13. So it's not a kite and it's not a trapezoid. So the way to figure out if it's a rhombus or a square is to figure out the side lengths and if the lines are perpendicular. So I had A, which would be like down here, and then I had B, which would be in this quadrant, C, which would be in this quadrant, and D, 2, negative 2, which in this quadrant is B. So A is here. B, I've made a mistake in drawing this. Probably made the mistake before. B is 1, negative 1. Okay? So B and D are actually in the same quadrant. I really just want to make a note here so that I can figure out negative 1, negative 4 to B. So I have one side length, AB, and another side length, 1, negative 1 to 4, 1. So I want to determine those slopes. And if they are negative reciprocals, then they're a square. I've made a mess here of this drawing. And my point is, yes, if I had graph paper, I could do So one of the things that I like about making these reviews and making these videos is it allows me sometimes to say, hey, wait a second, we didn't really discuss that concept very clearly now that I think about it in class. So let's make sure that we understand sometimes some intricacies of what a test, certainly what a standardized test might ask of us. So in the next few problems, they talk about rhombuses. And there's a lot of references or types of questions involving rhombuses and kites. So at first glance, the way our book kind of sets it up and the way it was presented in class was we learned about all different types of parallelograms. And then we learned about quadrilaterals that were not parallelograms, being trapezoids and kites. Then they ask a bunch of questions about rhombuses and kites, and it gets a little confusing. So what I want to do, and I'm doing this, you're not going to see it on there, is while I'm doing this, I'm looking through the book here to find what the actual definition in our book of a kite was. The actual definition of a kite is a quadrilateral that has two pairs of consecutive congruent sides, but opposite sides are not congruent. That's the definition in our book. But unfortunately, when you start delving into the world of geometry, that is not really the definition that is considered across the board in geometry. They've actually simplified the version here. And the version that's really true should say, a kite is a quadrilateral that has two pairs of consecutive congruent sides. That's where it should end. So this is what we think of typically as a kite, where this side and this side are congruent and these two. And that's really, when you get out of this book, what a definition of a kite is. The part that says, but opposite sides are not congruent, it actually should say something like, but opposite sides are not necessarily congruent. What this means, draw it this way, is that a rhombus can technically be considered a kite because it still has the two pairs of consecutive congruent sides. So while this doesn't apply to our definition in our book, I did some research and did some looking, and the definition in our book is not really what's held up across different forms of geometry, and not the way an EOC is going to expect you to think of a kite. So all rhombuses are actually kites. The way our book presents it, this would have been considered false, but it actually is a true statement. All squares are rhombuses, that's true, which yes, also means technically a square is a kite. Every kite is a rectangle. That's false. Kites are not rectangles, okay? And all squares are quadrilaterals, that is true. So the answer for 23 is C. But to be able to tell whether it's C or A, I actually had to go outside of our resources in this class and get a better definition for kites. Which statement is false? Some rhombuses are rectangles. Well, some rhombuses are rectangles, that's true. Every rhombus is a quadrilateral, has four sides, that's true. Every square is a parallelogram. That's true. Every parallelogram is a rhombus. No, every parallelogram is not a rhombus. For instance, make a very obvious parallelogram here, where these sides are congruent and these sides are congruent, but not all four sides are congruent. So which statement is false? It's D. And changing the color again. Which statement is false? If a quadrilateral is a square, then it is not a kite. That actually is a true statement when you look outside of the resources of our book. Some parallelograms are rhombuses. That's true. All parallelograms are quadrilaterals. That's true. If a quadrilateral is a rectangle, then it is a kite. No. If it's a square, then it's a kite. But if it's a rectangle, it is not a kite necessarily. Here's a rectangle. Pretend those are 90-degree angles. The opposite sides are congruent. The consecutive sides are not. Lateral A, B, C, D has vertices of -2, -5, 8, -5, 6, -1, and 0, -1. What type of quadrilateral? So I know you guys don't love these, but I'm going to do a very rough sketch. So -2, -5. I'm going to put the A there. B, 8, -5. Ooh, so I can tell that's going to be a straight line. Nice and easy. C, 6, -1. So that's C, and D is 0, -1. Okay, well this is making it a little bit easier than the last one we did because I can see that I have two side lengths there, these red side lengths that are obviously parallel. They both have a slope of 1. They're both horizontal lines. So if I can find the distance of each of these, I can know whether they're congruent. So right now, slope of AB is equal to slope of DC, because this one says explain your reasoning. And I said on the review, it's going to be actually be a few extra points on the test, so let's pay attention. So this one isn't too bad though. From -2 to 8, that's 10 units long. And from 0 to 6, that's 6 units long. So D is 0, starts here, and it goes to 6. So this is not right now looking like a parallelogram, obviously. The opposite sides are not congruent. So AB is not congruent to DC. Doesn't look like it here, but AB is actually a little bit short. I'm going to see if I can improve my drawing. And B should be all the way over here. Okay. Now, so this looks like it's probably a trapezoid. I want to determine whether it's an isosceles trapezoid or not. So the way to do that is to find the length of the legs. If the length of the legs is equal, then it is an isosceles trapezoid. So A to D. So the length of AD is -2 minus 0 is -2 squared is 4 plus -5 minus -1 is -4 squared is 16. So AD is equal to 4 plus 16, which is 20. The square root of 4 plus 16. So the length of CB. Okay? 8 minus 6 is 2 squared, that's 4. -5 minus -1, so -5 plus 1 is -4 squared is 16. So these are congruent. So the most exact name is an isosceles trapezoid. And for your description, you would say AB is parallel to DC. AB is not congruent, congruent sign with a line through it, to DC. But AD is congruent to CB. So I have a pair of bases that are parallel but not congruent and legs that are congruent. I meet the definition of an isosceles trapezoid. Hope all of this has helped you to be able to study well for your test. If you missed any of the answers somewhere along the way, you can freeze this, look through this. Here they all are.